Hey guys, welcome back to my channel called How To. Today in this lecture, we're gonna have an understanding how we can configure IPsec site-to-site VPN using IKE V2. Okay, IKE version 2, right? So previously, we had, I believe, like I have a couple of videos for this site-to-site VPN using IKE V1, right? Or we can say scam policy. But we even have an IKE V2 enhancement, right? And in real life, IKE V2 is in place, and we are using it. Okay. Just to just to give you about a brief regarding IKE V2, right? What we used to have in IKE V1, right? In IKE V1, like we used to have an ISCAM policy, right? uh, as I told you, like Hegel or Hegel, whatever you can term it as, HAGLE, right? Hashing, authentication, group, lifetime, and encryption. That's something we used to have in ISCAM policy. Okay, but in case of IKE V2, what we have here is IKE V2 have an IKE V2 proposals. Okay, we name it as IKE V2 proposals, right? It doesn't have any ISCAM policy. In place of that, we do have an IKE V2 proposals. Okay, like the same way, like in HAGLE, like in ISCAM policy we used to have an HAGLE, but in IKE V2 we don't have authentication. Okay, we have an hashing, group, lifetime, encryption, but we are not having any authentication here. The reason being, what IKE V2 provides, IKE V2 provides a flexible authentication to us. Okay, which is what we are not achieving in IKE V1. Okay, IKE V1 was not giving any, flexible authentication, but in IKE V2 we have in flexible authentication, right? Reason being, we can configure local pre-share key and remote pre-share key in our device. Okay, in our box. Where in case of IKE V1, we can only configure local authentication, right? Local key. We can't define any remote key. Okay, and even if you talk about IKE V2, IKE V2 have, built-in NAT traversal. Okay, NAT traversal, or what we can like NAT T, and that we can say, right? And even IKE V2 doesn't consume much more bandwidth as compared to IKE V1. Okay, and a couple of more advantages are there. Like if we can, like I think even IKE V2 supports EAP authentication. Okay, which is not being supported by IKE V1, right? And I think IKE V2 even supports MobiKey. I think MOBIKE. I don't know how we can pronounce, but I pronounce it as an MobiKey, in like a mobile-based authentication as well, right? Also, I think in Ike, the good the good part, what I like about Ike V2 is Ike V2 can detect whether a tunnel is still active or not, and that's something Ike V1 was not able to, but in Ike V2 we can achieve that. Okay, so I would suggest to go through, any documentation regarding Ike V2, study it well, right? But it was just an overview of Ike V2, what why we are having a lab regarding IKV2 and how we can configure IKV2, uh, how we can configure IPSEC using IKV2. Okay, this is all about. But just to give a brief regarding IKV2, I have given like couple of advantages over IKV1. Okay, so the topology here is we have in three routers. Okay, R1, R2, and R3. Okay, and we are using 12.1.1.0, and we have an loopback interfaces of 192.168.10/24 and 20.0/24. Okay, 12.1.1.0, as I told you, 1 and 2, 12.1.1.1, 12.1.1.2. 1 and 3, router 1 and 3, it's like router 1 means that 13.1.1.1 and 13.1.1.2. So there are a couple of steps, I have plotted here, so that you can make a note. It will be easy while while doing the configurations. Okay, once like you will do this lab at least like 4 to 5 times, then definitely it will be by heart. But until then, you can make a note and you can learn. Okay, and do practice. Okay, it's all about practice, right? So let's quickly jump into the consoles. What I have done, I have just configured the IP parameters as of now, right? On all those routers. Okay. So in R1, I have configured IP, like physical for one for physical and one for loopback. I can check the reachability. Yes, I'm reachable, right? So let's I know even from R3 reachability is fine. 13.1.1.1. Now, what's the first thing we need to have in mind is, right? Like router R1 is an ISP, okay? So term these IPs and as in public IPs in real life scenario, right? Whenever this will be like WAN interfaces, like these are in WAN interfaces of your security appliance or routers or whatever it is, right? These IPs need to be reachable, right? That public IP need to be reachable, okay? So let's check the connectivity first. Either I can reach out to R3, and that's my branch office, and R2 will be my head office, right? So let's check the connectivity first. Okay, I am in R1. Okay, this is an ISP. I'm not bothered about ISP. In ISP, I haven't. There is nothing. It's just we just know about its look like directly connected networks only. Okay. If I'll go to R2, if I'll verify if I can reach out to R3's WAN interface or not, the IP address would be 13.1.1.3. I think I'm not able to reach the R3's WAN one IP address, so I need to fix that part first. I think I haven't configured any default route over here. Okay, so IP route. Yes. So I'm gonna configure one default route pointing towards my ISP. IP route, any source, any pointed to one, sorry, 12.1.1.1. Okay, that's all. And even in R3, I think I haven't configured any default route. Right. So quickly configure it. Okay. Why I'm typing D? IP route, anything going towards anything 13.1.1.1. Okay, that's my. Now I'm from branch office. I'm gonna ping the WAN interface IP of my router R2, my head office. That's gonna be 12.1.1.2 because like that router is R2. See, I do have a reachability. Okay, it's reachable now. So we're done with the first part. Like we do have a reachability. Okay, so now the first part comes is create an ACL. Okay, the same way that we have configured prior, right, in IceCamp in previous videos. So config T, what I'm going to do is I'm going to create an one access list to match the interesting traffic. Access list 100, right? Permit IP. My loopback interface of art. I'm really sorry. It's an ISP, right? Not here. Not here. We need to go to R2. Um, Over here we need to create. Okay. So access list 100 permit IP 192.168.10.0 subnet, and the wildcard mask would be 255 0000255. Okay, pointing now going towards 192.168.20.0 0.0.0.255. Yes, that's it, right? So we have created one access list, okay, in R2. So the next part would be create an Ik V2 proposal. Okay. Now you can verify. There will be one default Ik V2 proposal. Okay, I'll show you how to verify it. So crypto Ik V2 proposals. Okay. Now when you hit enter, you'll be seeing one Ik V2 proposal that is default in the box. Okay. In every appliance, I think you'll be having one default. In this router, I do have. Okay. So we have one default Ik V2 proposals that we have. Like as I told you, there is no authentication in Ik V2, right? So we have an encryption, integrity, okay, PRF. pseudo random function. I think like PRF is termed as pseudo random function, right? And Diffie-Hellman group, right? So there is no authentication. Okay, so I'm not going to configure any IKV2 proposals because I have a default proposal as of now. So even in R4 I will be having a default, um, in R3 I'll be having one default proposal, so that will be negotiating. Okay, if you want to configure we can, but in this demonstration I'm two a bit save time. I'm not going to configure that proposal part. Okay, so second part is done. IKV2 proposal. Okay, we have a default IKV2 proposals created. If you want to create IKV2 proposal, even you can create. Okay, config t crypto uh, IKV2 proposals. Okay, give it a name. Okay, whatever it is, XYZ or ABC, whatever it is, and fill all those parameters that you want, and you can configure. As of now, I'm not. I'm going to. The third step is like create an Ik V2 keyring. Okay, so here what the difference is, we have an keyring. We need to create a keyring in Ik V1. What we used to do, we used to define a key, a local key, right? Crypto IceCamp key, CCI, and address of the peer, right? So and so. But here we need to create a um, keyring. Okay, so the command goes like this: crypto Ik V2 keyring. So give it a name. Okay, when you gonna like we need to give a name. So I'm in R2. You can give any name. So for this, I'm going to just give R2 only, the name um, of my local router, or like just I'm in R2. I'm just giving an R2 name. Okay, it's for the keyring. So I have given a keyring name called R2. Okay. So the next what we need to define over here is we need to define what would be our peer. So the peer would be PEER. Peer would be our router R3. Okay. So for me, router R2 gonna have internal. It's gonna like negotiate with R3, right? So um, just I'm so for me the peer would be R3. You can give any name as you want. Okay. That's all up to you. The peer is R3. Now now my peer is R3. So what is the address of my peer? Address would be 13.1.1.3. Okay, hit enter. The next part would be pre-shared key. Pre-shared key local. Okay, so here see the difference. So we're gonna define the local pre-shared key. That would be I'll type it as Cisco. So local pre-shared key of R2 would be Cisco. Okay, and the difference here, as I told, like we can even define the pre-shared key of we can even define the remote pre-shared key. Okay, in keyring. So the preset key for remote would be I'm typing as Cisco. So the remote preset I would like to have anything like Cisco or CCI. Okay, for this. So the local preset key is Cisco and the remote preset key is CCIE. That's it. So we are done with the keyring part. Okay. So what next? We have configured the peering. Sorry, keyring. So we need to create an IKV2 profile. Okay. So config t. Okay. Config t. Crypto IKV2 profile. So this is new. Okay. PROFile in this. So crypto IKV2 profile. Give it a name. I'll give it as IKV2 profile. Okay. Now see like IKV2 profile must have a local and remote authentication method. Okay, a match identity or match certificate statement. Okay, so it is just awareing, like giving us the awareness, like this parameter should be included in IKV2 profile. Okay, so it's like a good pop-up, or what you can say, like, yeah, just go for a pop-up, a display message. Okay, so now, or notification message, what we can do. Okay, like we are configuring IK V2 profile, right? So here, what we need to do, how I like, I have remembered this command is okay. In Ik V2, I need to create a Ik V2 profile, and even like, okay, match identity is there, right? Okay, so it is giving me help. There is a command called match identity. Okay, match identity for remote address. Okay, this is the command we need to have. So what we are doing, we are just matching the identity of remote a remote peer, a remote address. So for me, remote address would be 13.1.1.3. Okay, hit enter. Now authentication, right? Even it is saying like we need to have a local and remote authentication. So authentication local is my pre-shared key that we have defined, right, in keyring, that I have defined like Cisco and CCIE. So the authentication local, like I'm gonna use the local authentication method that is pre-shared key. And even authentication for remote would be pre-shared key only, right? Even you can have in two different authentication mechanism in IKV2. Okay, it's not that mandatory, like like both need to have an same authentication mechanism. No, we can have in different, I think. So authentication, the key, like the authentication mechanism, look, authentication keys we have defined, we'll be defining, authentication keys are different, like for local is different, for remote is different, right? But authentication method is same here, right? It's an pre-shared key only. Okay, so that's what I mean. So authentication local is pre-shared key, so authentication remote is pre-shared key. Now pull our keyring that we have configured right now. Keyring is our local. So my local keyring is, now name of my keyring is R1. Okay. So keyring local is R1. Why it is not matching? Sorry. Um, Keyring local, I think it's an R2, right? Great. Now end. So that's all. So what we have done, we have created our IKE V2 profile as well. Now rest, it's like all same, okay? Transform set, crypto map, and binding it to the interface. The only step, that the add-on step is creating an IKE V2 profile. Now go on creating IPsec transform set. The command would be crypto IPsec transform set called tset. Okay, give it a name. Okay, and then ESP, I would like to use DES, and for ESP for hashing, I would like to use MD5 HMAC. Okay, I'm done with my crypto IPsec transform set as well. So what's next? So next step would be I'm gonna create a crypto map. Okay, the step number 6. So the crypto map goes like this: crypto map. Give it a name called my map. Okay, IPsec crypto map my map. Give it a sequence number called 1. Okay, and then IPsec iscamp. Hit enter. Okay, the new crypto map will remain disabled until a peer and a valid access list have been configured. Okay, so we have configured all those things, right? Pre-checks have been configured. Then, so now what next? So in crypto map, what we gonna call it? We gonna call our all those parameters that we have configured right now. Okay, the first step would be first set peer. What's my peer? So for me, what would be the peer? My peer would be R3, 13.1.1.3, right? And transform set that we have just created. Set transform set, that is T set. Okay. Again, what we have configured? We have configured IKV2 profile, right? So call out IKV2 profile as well. Set IKV2 profile. What's the profile name? IKV2 profile. That's the name of my IKV2 profile that I have configured, right? IKV2 profile. So what next? We have even created a one access list, right? That in the first step. So call out match address 100, right? That's the name of like number of like number is like um, access list number. Okay, 100, and then end. That's all. So the last step is bind this crypto map to the interface, right? In R2's interface, the exit interface. So what I'm gonna do, config t interface fa3/1 crypto map my map. Okay, you'll see one notification that crypto map icecamp is on. Okay, now and now quickly you can even verify all those things. So crypto IP, so crypto IKV2 proposals, you can see a PRO proposal. Okay, you can see the proposals. So crypto IKV2 assay, no. So crypto IKV2, what else? IKV2, what I can show you right now is, I can show you that profile is new, right? Profile. See, what we have done, IQ2 profile, the name of my profile, right? My local WAN 1 IP address. Look in 13.1.1.3 that we have given, and remember, like we haven't given any subnet mask, right? While creating our uh, profile, we have just while creating a IQ2 profile, what we have done, match identity remote address, and we have only given the number, the IP address. Okay, you have, it has by defaultly picked up slash 32-bit mask. Okay, if you are not going to define a mask, it will create by default. What else? Local identifier, no. So the keyring we are using is R2, the name of the keyring. Okay. Mm, so a good lifetime is by default set. It's like 864 and like 86400, right? The authentication we are using for local and peer is preset key only. So pretty good command to to see our um, profile, IQ2 profile. Now what I'm gonna do, I'm gonna quickly jump into R3. Okay, now I'm gonna configure the same thing. Okay, so what is our goal here? Our goal is from R2's loopback interface, R2's loopback interface should be able to reach R3's loopback interface. Okay, packet will, so that's what we're gonna achieve here. Okay, so again, go to our step first. Okay, create an ACL over here, config T, access list 100, permit IP 192.168.20.0, 0.0.0.255, wildcard mask 192.168 are going towards my routers R2 loopback interface 255. I can even log it. Okay, log it. R3. Now first step is done. What next? Create an Ik V2 proposal. We even have Ik V2 proposal. So do so. Crypto Ik V2 proposal. As I told you, we have in default Ik V2 proposals over here as well, right? So go to step third. Ik V2 keyring. Okay. So crypto Ik V2 keyring. I'm gonna give it a name of my keyring that would be R3. Okay. So what else? We need to configure a peer. The peer would be my R1. Okay. So what else? We need to configure an address, right? So what's my peer address? It would be 12.1.1.2 because it's an router R2. Okay. Even you can specify a mask over here, but I'm not gonna specify. It will pick it as default. Okay, so address is done. So my preset key would be now the point here. So in R2, what we have defined the preset key for R3, the remote preset key is CCIE, right? So the preset key local would be my CCIE. Okay, so the preset key for remote is Cisco. What we have configured, Cisco, right? Right. For this, the local peer was Cisco, and in this router, the local peer was Cisco, and uh, the remote key was CCIE. Wherein for my branch office for R3, the local key preset key is CCIE, just vice versa, and the remote it would be Cisco. So local and remote key pair is done, like key is configured, and that's the part can end. Now what are we gonna do? We're gonna jump into our step number 4, creating an IKV2 profile. Crypto IKV2 profile. IKV2. I just tend to give the same name just to avoid the confusion. IKV2 PROFI profile, right? So the local and the so all those things. So identity match identity remote address should be I mean R3, so it's going to be like 12.1.1.2. Okay, what else? Match identity remote address this and local and remote authentication method. So authentication local, okay, authentication local would be my pre-shared key. Okay, we have multiple options of authentication part, but we are using pre-share, so I'm gonna go for pre-share key. Authentication remote is also pre-share, right? Method is pre-shared only, pre-shared key, and pull our keyring that we have configured. Keyring would be R3, right? Mhm. So what keyring I have configured here, I'm not, it should be R3, but I think I keyring is R3, right? So keyring local, okay. So I forgot to type the command called local. So keyring local is R3, okay, and so keyring is done, IKV2 profile is done. Now what next? Now it goes simple. It's like config T, create your fifth step is creating an IPSEC transform set, crypto IPSEC transform set called T set ESP. It need to be same, okay, in both the routers. I forgot what I have configured in R2. Let's have a look. In R2, my transform set parameter was so run include transform. Hold on a second. It's taking time, huh? I know my RAM utilization is like pretty high. It's like 90-91%. Okay, it's keep the pop-up. So the crypto IPsec transform set T set ESP DES ESP encryption hashing would be MD5 and HMAC, right? These need to be same. Like symmetrical uh, transform sets between routers. Now, what next? The next step would be creating a crypto map. Crypto map called my map. Okay, sorry. Crypto map, my map, give it a sequence number and IPsec. I scammed, hit enter. Okay, call it all those parameters that we have configured. Call out first set the peer, set peer R3 12.1.1.2 routers R2 WAN interface IP. Okay, and call out our transform set as well, a set transform set called T set. Okay, what next? Call out your IKV2 profile, create set IKV2 profile called IKV2 profile. Okay, that's the name of my profile. So what next? I think this is call out, this is call out. Look, I just go like reverse. Okay, I just call out, I'm in crypto map. I had call out transform set IKV2 profile. Now what next? Keyring. um, Keyring is already call out in our profile, so no need to call out keyring. What we why what we need to call out our ACL. Okay, so match address 100 and then end. Okay, so the four parameters, like, okay, quick check, access list is called out, equity profile is called out, and transform set is called out, and then peer is set. Yes, done. Okay, hit enter. So crypto IKV2 as a, there is no any associations right now. Okay, crypto IPSEC as a, so crypto IPSEC as a, no, right? Because we haven't generated any traffic. Okay, so what we need to do is I'm gonna generate a traffic from R2. So the logic here is what's gonna happen. See, from R2's loopback interface, so think in this way, R2 is having like multiple servers. I am using my mouse. Okay, so R2's loopback interface, like it is having an IP address called 192.168.10.10. Okay, so it is having 10.20, something like this. Okay, so like this is an network behind R2, right? So what's happening? We need to generate a traffic from R2's loopback, like somewhere like R2's loopback interface means like think like R2 is having one network behind it, and we're gonna generate traffic, right? So from R2's loopback interface, like from 10.1 from here, what we need to do? We need to generate a traffic that will land to R2, and then R2 will push that traffic to our tunnel that we have created. Okay, so we need to generate traffic here to form our tunnel. Okay, to, so the traffic will be generated. Okay, it will go to R3 and it will come back and forth, right? It will come here, then that's how our uh that's how we'll able to form our IPsec site to site tunnel and the reachability as well. So let's quickly jump in R2's R R2's loopback interface. Why it is not disappearing? Yes. Okay. Now I'll go to R2's my head office. I'll generate a ping 192.168.20.1 source from loopback 0. Okay, this is important. Else, if you'll just ping from 192.168.20.0, it will pick its exit interface IP, and it won't be able to communicate because it won't be matching any ACLs, right? So I'm sending a ping. Let's wait. I'm really sorry. I think something is wrong. I'm not sure what is wrong over here. Okay, in R3, did I binded my profile? I don't know. Okay. So crypto map. I think I do have a crypto map called my map. So interface. So run interface inc crypto. I think I tend to forget one thing that's called step number 6. I haven't binded my crypto map to my profile, okay, to my interface. Seems so. Let's so interface fa0/0. Okay, config t interface fa0/0. Crypto map my map. Okay, exit. So the crypto map is on. Now let's go to R2 and generate the same traffic from R2. Mhm. Something is going wrong. Let's do our troubleshooting parts. Uh, can I ping 192.168 dot sorry, can I ping 13.1.1 dot 13.1.1.3? I can. Um, so access list 100, permit from 192.110.0 255 20.0. So I think my traffic is being matched. I can see the 20 matches. Something is wrong over the tunnel, I think. So we need to have a look. So run Ik V2. So crypto Ik V2 profile. So crypto Ik V2 profile 12.1.1.2. Okay. Preset key, that's fine. Keyring is R3. Okay, keyring is R3. Mhm. So let's verify keyring. So crypto Ike. So crypto Ike V2. Uh, so run as a keyring. Okay, it seems good. R3 R3. Let's go to R3 and verify what's wrong over here. I I would like to verify from access list. So access list. I okay. Access list is 100. 20.0 10.0. Okay, it's fine. So I so crypto Ik V2 proposals. So crypto Ik V2 profile. I think this is the mistake that I have done. 12.1.1.1. Not yes. I think it should be 13.1.1.3. Okay. In Ik V2 profile. So let's quickly go to R2. I did a mistake, I think, right? So crypto Ik V2 profile. No, it seems good. It's in remote 13.1.1.3, 12.1.1.2, local peer, and am I missing something? So IP interface brief. Do I have an 20.1? Yes. Mm. So crypto map R3 12.1.1.2 IQ profile access list current peer for R3 it's 12.1.1.2 IQ profile transform set t set in R2 so crypto map 13.1.1.3 extended IP access list 100. Okay. I found one mistake. Okay, see what I have done is in access list rather than look our IP parameters are the network we are having in our loopback interface is 192.168.10.0 and 20.0, right? I think here it's fine, right? But in R3, you can see my access list. Um, I tend to use 193. Okay, so this is the mistake I think I did. So let's quickly correct this part. Okay, we did a good shoot over here. I think let's. I think no access list 100. Access list 100 permit IP 192.168.20.0 and 192.168.10.0 log it. Okay, I'll again verify my access list. So access list 100 to 192 going from source to destination, log it. Okay, I let's see. Okay, I think this is the mistake I did. So I'll go to R1 and I'll generate a ping again. Why I'm going to R1? I need to go to R2. Why I'm okay. Ping 192.168.20.1 sourced from loopback loopback 0. Yes, see, um, now we are able to. Okay, one packet is dropped. I think probably for negotiating a tunnel, right? Now, when you will verify, so crypto IPSEC SA, see, now you will see all those um, negotiations. Okay, like four packet have been encapsulated, four packet have been encrypted, and four packet have been decapsulated and decrypted. Okay, so the local identifier, like the local and the remote, okay, so the remote address and mask, like we are calling it calling out in our ACL, right? What crypto map we are using, okay? What's the local address, right? And what's an current outbound SPIs, inbound SPI, okay? I have told but what's SPI is all about, right? So what's status like active right now, right? So replay detection support is like yes, it's supported. And what's transform set we are using, right? So everything you can have a look of like from here, right? You can have a good picture. Okay, so what I like to show you, so crypto IPsec assay is done, right? So crypto IPsec assay is this. So crypto Ik V2 assays. Okay, so in Ik V2 assays, even you can have a look. Okay, what's we have. So in Ik V2 assays, my tunnel ID or source ID is one, right? And what's what's here the local address, right? That the one interface IP, the public IP of my local, and the remote public IP, right? And the status is ready. Okay, and we have an active lifetime of 86400, right? And this timer 88 seconds, I think it will increase. Okay, this timer will be increased. This timer shows like the 180 128 seconds means like uh so the lifetime is 86400 until unless this timer will reach out to this value, that tunnel will be that never ship won't be going down, it won't renegotiate. Okay, so once this lifetime timer is expired, then that tunnel negotiation will reoccur. Okay, that's what it means. See, it will keep on increasing. Okay, so from last 126 130 164 seconds we are having this uh, uh, we are having our tunnel up, right? What hashing we are using, what Tefe Helmet group we are using, authentication is preset key, right? So all those things you can have a look in IQ2 essays, right? One more thing I can show you over here is one beautiful command. So crypto engine, I think. So crypto engine connections active. Okay. So in So we have an so we are using this algorithm for IPSEC. DSMD5 and DSMD5 are proposals, right? So see, like for traffic was encrypted using this proposal, right? And it encrypted and it was decrypted, right? And our local peer, and for Ik V2 profile, you are using SHA and AES 256 bit algorithms. Okay, so even you can have a look on this part. So I think yes, we are good here. We have successfully configured our IPsec side-to-side VPN between two different offices or remote locations. One is my head office and one is my branch office using Ik V2. Okay. So do practice. Okay. Do let me know if you have any doubts on this. Put it on comment section below. Do share it, guys. Do like it if you find this video was informative for you, and keep providing the support. And thank you so much for watching, and see you until next time. Take care. Bye bye.